I want to look at difference of squares, and I'm going to factor this and talk about the formula that we use with factoring squares, and then how to apply this to solving a polynomial or other types of problems that might relate back to this if we see it. To begin with, I'm going to use some long division. I am going to factor out a term of a minus b, if possible. The first thing that you do with long division of polynomials is you create a ratio of the leading terms. And that reduces to a. This is going to be part of the quotient, and we're going to use this to multiply it by this. And we subtract this from this. You see some sign changes because I'm subtracting this whole polynomial from this polynomial, so we're looking at this where the negative is distributing across this. That's where these signs come from. So the a squared is gone. We have ab minus b squared. Again, we're going to create some ratios here. So this gives me b. So I'm going to add b up here in my quotient. Again, we're going to take this term and multiply it by this term. This is going to give us 0 here. So this is the other factor, and we have all the factors. All right, so a squared minus b squared is going to have the factors of, the first factor is a minus b, the second factor is a plus b. So whenever we see a term here that's squared minus a second term that's squared, we can take those bases and place them here. Let's take a look at x squared minus 36. I want to use a difference of squares to factor this. 36 is a square term, but I need to have it in the form of a base to a power of 2. So I'm going to rewrite this as 6 squared. So this is x squared minus 6 squared. So now that I have this form, I can use this. Everywhere that I have my base a will go in the first position. Everywhere that I have my base b is going to be in the second position. So I have x minus 6, that's these two bases. And then I'll have x plus 6, again, these bases. If you go to the trouble of multiplying these together, use some double distribution, you should come back to this term. Now let's look at a polynomial in a little different context. Let's say, for instance, we are given the problem 3x plus 1 squared is equal to x minus 2 squared, and we're solving for x. You may want to start out with using some square roots here. You may choose to expand both sides. We want to use this formula, this rule here, to solve this. So the first thing that I want to do is I want to move both my square terms to the other side, so that I'm going to have, this is going to be my a term, this will be my b term. Since I subtracted this, we have to remember to put a 0 there, since that minus that is 0. And then we have this minus this is over here. This is my a term and my b term. Remember, I'm wanting to expand this. So I'm going to make a little note of a and b here. So I want my a 3x plus 1, that's A, minus B. This was B. Now, just like when I did my long division, this negative is distributing over here when I'm subtracting it. So I have all of this. So that's this first parenthesis here, and I'm going to look at the second parenthesis. So everything here added. And again, we just did substitution of this thing into this thing, and these are equal. So this, since this is equal to 0, this is equal to 0 by transitivity. We're going to simplify inside of our parentheses now. 3x minus an x is going to give me 2x. And then 3. Over here we have 3x plus an x, that's 4x. 1 minus 2 is negative 1. Now, we're going to use the zero product property, set each of these equal to 0, and solve for x. Call this case 1 and case 2. I'm going to subtract 3 from both sides. And then we're going to divide by 2. So I have x is equal to negative 3 halves. And over on this side, I'm going to add 1 to both sides. And then divide by 4. So I have 1/4. If we plug in negative 3 halves into here, we should find that this is equal. If I substitute a quarter in for x here, we should find that those are equal also. And we've applied this rule to solve a problem like this. So in this problem, we didn't even have to take a square root. Something interesting. Hopefully you find some mathematics in your area of the world to enjoy. Cheerful calculations.